had a good feeling there was going to be one. Why are there 3 tables at our spot?
Like, did she say, like, specifically, I want one person more in the house?
You're all up.
And then just got out of the rain.
I don't like this. Can we move this? We've had it here before. We're sitting here. Actually, I think here's the best place. Because if I'm sitting here, I'm staring at all the time. I was a research paper. I don't know if you remember Friday. So on an extra day, I went to 2,200 words.
Oh, yeah.
And he hasn't responded to me. What? What did I say? Oh shit. No. Point is, I felt bad, so I gave him an extra 4 pages to read. I don't know if he's gonna like that or feel disappointed.
What?
Twice as long as he did with the other pages. It's almost 9 pages long. Put out my phone. I know.
That's a fantastic day. What? Yes, you do have one.
What the hell is this? Like almost
Reagan. Are you sure? That's old.
I'm not reading. I don't have to read it.
What happened? What did you say?
I feel like the other 8 lines weren't very necessary.
Okay.
Is that just something I spelled hair?
This thing right
You spelled hair wrong.
No, it's 4 quarters in a year, right?
All right, guys, let's get started here. Welcome back. I hope you all had a nice, restful break. I will remind you that before the break, we had finished up half of the unit, which is why the last test was only 50 points. And so now that we are coming back, we are doing the other half of the unit. So I don't have this listed under the agenda. Boys, y'all either need to move back or you got to cut your conversation out. I don't have it under the agenda, but you may decide today that it would be a good idea to look back at some of the log properties from 3.2. Those log properties are going to carry over into our other 2 sections, 3.3 and 3.4. So 3.3 we're going to spend just 1 day on today. This is focuses on expanding and condensing logarithms. Another thing you should have seen in Algebra 2, but you may not remember it. So the book assignment is a little bit longer as far as number of questions, but actually most of the questions are very quick, can be like 20-second questions. So should be able to get all this done in class today. But even though we're only going to spend 1 class period on 3.3, we will not be quizzing 3.3 next class. We will actually do 3.3 and 3.4, quiz both of them together, We'll review both of them and then test both of them. So there's just not enough material in 3.3 for a full quiz. So we need to talk about how and what it means to expand and condense. First thing you should know is that expanding and condensing are exact opposite processes. So if you understand one of them very well, the other one is just going the opposite direction. So the first one, if you look this up in the textbook, is it's going to say if you have two logs of the same base, I'm just saying base A to be generic, if they are separated with a subtract sign, you can condense them into a single log of the same type. So if this is log base A and this is log base A, it's going to condense to a log base A. Does anybody remember from Algebra 2 how subtraction condenses? Very good, with division. And I'll try to highlight that each time. So B comes first, so it's the numerator. C comes second, it's the denominator. So this is how it would look if you found it in your textbook. But to actually use it for question 1, notice this is log base 3, this is log base 3. So you could condense them into a single log base 3. Since they're separated with subtraction, when you condense them, you condense with division. Log base 3 of 5 minus log base 3 of 2 is the same thing as log base 3 of 5 over 2. The other one, which even if you didn't remember this one, I bet you could make a good educated guess here. If I have two logs of the same type again, but this time they're separated by addition, how do you think those two would combine? Multiplication, very good. So it would be B times C. So again, this is just a generic way, not using actual letters, but just generic letters, numbers A, B, and C. But to apply that to question 2, log base 3, so that could be condensed into a single log base 3. Because they were separated by addition, you could condense those with multiplication. Log base 3 of 10. Same thing. And there's not a ton of examples of this today, but there are a few showing you some examples of why you would want to be able to condense. But I specifically picked out one right here. This has nothing to do with 3.3, so you don't have to worry about studying this at this point, but I still want you to have it down for your notes. When we get to section 3.4, and 3.4 is all about solving equations, even things like this, there is not much that you can do. In fact, there's very little that you can do. But if you know how to condense, you could say, well, I could squeeze these two together into a single log base 5. Addition condenses to multiplication. And if you know to condense and you know how to condense, you can at least finish the question with some of the tools we talked about before break, like switching it from logarithmic form to exponential form, and then normal solving stuff like undoing times with divide. So, not one that you can really do any other way, but if we can condense them, it allows us to solve some different equations. Again, we're not solving equations in this section. I was just showing you one quick example of where condensing unlocks the doors for some other stuff. Now, again, if you can condense, you should be able to expand because it's just the exact inverse. It's going the other direction. So if I see they're condensed with division, I know that means I could expand with subtraction. The only thing I would add to this that you want to make a habit out of doing, especially when you check your answers in the back of the book, they're not going to leave it log base 3 of 3. You have to remember that this is saying 3 to what power gives you 3. And if they're condensed with multiplication, I know that I could expand them with addition. Again, the exact opposite thing I did in questions 1 and 2. The answer becomes the question becomes the answer. And of course, this one simplifies nicely, so we might as well go ahead and change this. Now, I will warn you that since it seems like these two, like, it's easy to want to make a little rule in your head that division becomes subtraction, multiplication becomes addition. I understand why you want to do that, but you need to be careful. There's only 2 ways to condense. Subtraction and addition can condense into division and multiplication. Division and multiplication does not condense. If this had been division or multiplication, or this had been division or multiplication, you couldn't do anything. On the flip side, a single logarithm with division can expand the subtraction, but if this was subtraction, it would not expand at all. So don't oversimplify the rule. There's 2 ways to expand, 2 ways to condense, and that's it. Simply remembering division and subtraction go together and multiplication and addition go together could mess you up, because that's true for one way and not the other way. Okay, to then give you one quick example of why you might want to be able to expand. Again, there's a handful of reasons, but I would like you to go ahead and copy down both ways here. I'm going to show you 2 ways to solve this. The way we would have done this before the break in section 3.2 was just using exponent rules. So 7 to the negative 4th in the denominator is like 7 to the positive 4 in the numerator. And then we could use our log properties. 4 is an exponent on something I'm taking the log of, so 4 can come down out front. Log base 7 of 7 would be 1, so your answer comes from 4 times 1. That's still fine. If you are more comfortable with exponent properties, that's probably still the way that you would want to work that. But I need you to see that you should now have options because of expanding and condensing. If I have a division inside of a logarithm, I could expand this with subtraction. And then log base 7 of 1 would be 0, because 7 to the 0 gives us 1. Over here, I could bring the negative 4 down. Log base 7 of 7 would be 1, so your answer comes from 4 times 1. I just want you to see that you get the same thing both ways. So you need to be able to expand anyway. You need to know your exponent rules anyway, but on questions like this, you really could pick whatever way seems easier to you. They're always going to give you the same answer. All right, there are a few logarithm properties that are going to come up more than others. So I think this is on your back page at this point. So if I asked you to condense this, question 8, sure, this is a log base 3 of something, and this is a log base 3 of something. And we know subtraction is going to condense with division. The problem is this 2 is in the way. This doesn't look like the questions on the front page. We need these coefficients in front of the logs to be 1. So if it's not 1, you need to, normally, if you have an exponent on something you're taking the log of, normally you would bring that down. But in this case, I would like to bring it up as an exponent. So you have to get that 2 up and out of the way first. And then you can condense. So when I bring the 2 up, it becomes an exponent on 5, which is where my 25 is coming from. But don't just pretend like that 2 is not there. You need to get those coefficients up as exponents before you condense. Likewise, if we're going the other direction, at the end of the question, we're going to undo that. And this is going to be important when you check your answers, because your answers aren't going to look exactly the same as the book if you don't do that. But if I ask you to expand this, this is 9 times x squared. So we could do log base 3 of 9 plus log base 3 of x squared. And the back of the book's going to do two things. One is going to say this comes out to be 2, so we might as well change that. And then secondly, we need to bring those exponents back down. Just like we're bringing the exponents up to get them out of the way in this direction, if we're going the other direction, it's implied that you should bring that to come down at the end of the problem. This is how it's going to look at the end. So you need to understand why that 2 doesn't say an exponent on x and instead comes in front of the logarithm. So condensing, move the coefficients up as exponents. Expanding, at the end, bring the exponents back down as coefficients. Okay, I've only got 2 questions on this entire set of notes that I'd like you to do as practice, as guided practice. So if you would quickly try 11 and 12 to make sure you're not falling into the common traps. And I will warn you that 12 has one step that is a little trickier than normal, but I also think that 12 is how it is often asked on the ACT. So I want you to try it first before I tell you what to do, so that you know if that is something that you might need to look at again. Okay, I would say 11's the easier of the two. So you simply need to know that subtraction is going to condense into division. Natural log is going to condense into natural log. But the one thing about this question is you cannot ignore this 3. You've got to deal with it before you can condense. You can't just pretend like it's not there. You can bring it up as an exponent. 3 comes first, so it's the numerator. X plus 1 cubed comes next, so it's the denominator. That's what you were aiming for in 11. We okay with that one? Okay. Then 12, so I'd say there's a couple hurdles here. First one shouldn't be too much of a problem. Division is going to expand as subtraction. I'm not worried about that. But even after you do that, there's a hurdle of this expands again because y squared and z cubed are being multiplied. So I could expand these two with addition. And in question 9-10, we talked about if you're going this direction, you should bring the coefficients down. So the 2 needs to come down, the 2 needs to come down, and the 3 needs to come down if you're going that direction. But I still have a mistake here, and this mistake is what I'm concerned about and why I have it as a practice question. Any guesses about what I did not do? No guesses? Okay. So this was subtract all of this, right? So when you expand it, it's still subtract all of this. It's not just magically subtracting the first half of it and then adding the second half. You either need to put parentheses in to make sure you subtract the whole thing, or distribute the negative. And when I have seen that on ACT type stuff, they always put one of the wrong answers where they leave this sign wrong to see if you knew that it had to be distributed. Again, I was subtracting all of this, so when I expand it, it's still subtracting all of this. So you either have to have parentheses or you have to distribute. But if you don't distribute to this one, then that part is wrong. So as I said, that's not easy for most people to catch, but.
Will you accept both the parentheses?
Oh yeah, I mean, those are equivalent, so that's fine. I don't have a preference there. I'm just telling you, people forget that sign. All right, and then when we move on to the book assignment in just a second, I think the first like 5 questions are about change of base, and we talked about change of base before the break, but it comes back up here. So it wants us to write what this would be equal to using common log. Common log just means log base 10. So one way to estimate log base 3 of 7 would be to go to your calculator and do log of 7 divided by log of 3. And then B, doing natural logs. You could also do a natural log of 7 over natural log of 3. But you could type in either one of those two into your calculator, and then you can round it to 3 or 8 or 9 decimals, or you can be much more accurate. But you still need to know change of base. All right, and then finally, the last little review thing is there's quite a few radicals in these. So you need to remember that a square root is the same thing as an exponent of a half. A cube root, you usually want to think of that as an exponent to the third. A fourth root is like an exponent to the 1/4, etc. The reason that's going to come into play is if you had a question like this and it says to expand, this is 7 times the square root of x, so I could expand with addition. That's not what the answer is going to look like, and you're going to think that you're doing something wrong. What the book is going to do, and any mathematician's going to do, is they're going to think as the square root as an exponent of a half, and then because we're expanding, this shouldn't be left up here. This should come down before you're finished. So you check your answer and you have no idea where this 1/2 is coming from. The 1/2 is coming from thinking of the square root as an exponent, and then because of log properties, it can come down out front. So that comes up a handful of times as well. Okay, so I know most of that is pretty quick. I'm assuming you guys did expanding and condensing in Algebra 2, at least a little bit. Okay. Is there anything from the notes you want some quick clarification on? Okay, then let's go ahead and slide over to the book assignment. Again, the book assignment has a lot of questions, but most of the questions are very quick. So to start off here, I'll do a couple timers to give you some good opportunities to easily ask for some help that everyone can benefit from. So again, the first couple questions have to do with change of base. The next couple questions have to do with trying to do logarithms without a calculator. Then there's a couple on expanding, a couple on condensing, and at the end there's a couple on expanding and condensing that are a little messier. But so if you'd copy down that assignment and try to work through the first handful of questions in about 15 minutes, and then I'll give you a chance to ask for some help on the board about 15 minutes from now. again, we only spend this one day on section 3.3, so you need to make sure that you feel pretty comfortable with this, because we won't spend more class time on this. Also, I do, even though I'm not insisting you turn this in before Wednesday, I really feel like you probably will finish this in class today. I think everybody first period did. And it is opened up in Google Classroom. So even though it doesn't have to be turned in by the start of class Wednesday, you should probably go ahead and turn it in anyway, so you don't forget to do that. So I'm just telling you that now for those of you that work faster than others. and offer some help here. So trying to stick to the early questions first. Does anybody need help with questions 1, 2, 5, or 9? 1, 2, 5, or 9? Okay, then what about 1, 2, 5, 9, or anything 19 through 32? 20 what?
21.
21? Sure. Okay, so this whole section here says that we should be doing these without a calculator. So I guess you could type it in your calculator, but you're not getting the practice in that you need to. So first thing that I noticed about this question is this cube root. So like the very end of your notes, I would change this cube root into an exponent of a third. And the reason that's helpful is now the 1/3 is an exponent on something I'm taking the log of. So the 1/3 can come down out front. What about this part? Are you okay with this part, or do you want me to go more in there? You're okay with that part? Okay. So then this 6 to the first would be 6. So if you need the reciprocal of that, it would be 6 to the -1. And again, you could do this with exponent rules, or you could expand this. You've got some options there. But in the end, it should be -1/3.
Thank you.
Okay, others 1 through 32. Chase, was that yours that you needed to ask? Okay. Anybody else have any others ready to go? Okay. I will bug you again in about another 15 minutes. So if you get hard stuck on a question, just skip it temporarily.
Oh, yeah. He's got way better than this. He's way better. When you say nothing at all, it's his best song. That's his best song. I know Keith Richards. I'm no stranger to the Rain's a banger, too. No stranger to the Rain's a banger. I know my music. I know my country music, boy.
All right, has anybody found anything up through, I don't know, question 59? Yeah.
So I looked at the back because I didn't know, but can you explain number 23?
23?
Or 23 or 24?
Sure. We can do both of them because both are the same problem. Okay, so the problem with both of these, if you remember before break, sometimes we solve some really simple equations and our answers could be negative, but when you plug them in, you can't take the log of something negative. Do you remember that? So you can't take the log of 0 and you can't take the log of negative. So as soon as you recognize that, you've got your answer to both of these. To help you remember that though, if you think about what these graphs look like, log base 2 of x looks like this. He doesn't exist at 0. He certainly doesn't exist at -2. Also, you could phrase it as 2 to what power gives you -2, and that doesn't make sense. There's no exponent that makes it negative. You can make the exponent be negative, but that just makes it flip the fraction. It never makes it become negative. And then same with this. Log base 3 of x basically looks the same. Doesn't exist at 0. He certainly doesn't exist at -27, so it doesn't make sense. You can never take the log of 0, and you can never take the log of a negative number. Your answers can be 0, your answers can be negative, but you can't take the log of them. Okay, some others, yeah. 28. 28, 2 times the natural log of e to the 6th minus the natural log of e to the 5th. Probably what I would do is bring these exponents down first. So when you bring this down, this becomes a 5. So there was a 1 there, so when you bring it down, it's 5 times whatever was there. So same thing here, when you bring this 6 down, it's 6 times whatever was there. Do you remember what the natural log of e is? Okay, so this is really like 12 times 1 minus 5 times 1, so it should be 7. Yeah,
22.
22. Log base 2, 4th root of 8. I don't know, I think you could probably do this one 2 different ways, but the second way is a little bit abstract. What I would probably recommend, like we talked about on your notes, is a 4th root is the same as an exponent of a 4th. And then once you see it's an exponent on something you're taking the log of, that can come down out front. And then this comes out to be a nice whole number. 2 to the 3rd is what gives you 8. So your answer should come from 3 times 1/4. The other way that, and I don't know that I've ever thought of this until this morning, but you could also maybe think of it as like 2 to what power gives you 8, and then it needs to be a 4th root. And 4th root's the same as a 1/4. So I don't know. That seems a little sketchier to me. I like this better. All right, y'all got more ready to go?
26.
26 and 29. Let's do 26 first, since it's numerically first. Okay, you could do this one 2 different ways, so I'll show you both ways, and then you can decide what you think is easier. Square root is the same as an exponent of a half. So e to the positive 1/2 in the denominator is the same thing as e to the negative 1/2 in the numerator. So if you think of it this way, now you can bring the negative 1/2 down. Natural log of e is always going to be 1. So your answer comes from negative 1/2 times 1. So that would be doing it with exponent rules. Or you could do expanding and condensing. So since this is division, you could do natural log of 1 minus natural log of e to the 1/2. This is going to be 0 because e to the 0 gives you 1. This can come down here, and you still end up with negative 1/2 either way. So just whatever you prefer. Obviously on a test, it would be great if you did both ways just to make sure your answer is consistent. Okay, is that enough there? Okay. And then you said 29? Willa? You said 29?
Yeah.
Okay. Yeah, actually 29 and 30 are my favorite questions in these. Because you really only have one option here. This is saying 5 to what power gives you 75? And I know it's something between 2 and 3. It's not, careful, it's not multiplication. 5 squared is only 25, 5 to the third is 125, so I know it's between 2 and 3, some fraction. Over here, this is between 0 and 1, because 5 to the 0 gives me 1, 5 to the first gives me 5. So this is some weird nasty decimal, and this is some weird nasty decimal. But we can still do this one without a calculator if we know how to expand and condense. Since these are both log base 5s, we could condense them into a single log base 5. Then you could say 75 divided by 3 is 25. And now all of a sudden it looks in a format that I can actually do in my head. So both question 29 and 30, you actually have to condense those to be able to do them without a calculator. Is that enough? Okay, if y'all have more questions ready, go ahead and let me know. No sense in waiting. What you got?
Okay, do 31.
31? I will. Okay, 31 wants us to figure out what log base 4 of 8 is. Okay, so I know I could, and I'm trying to do this without a calculator since that's what the directions say. So I know 4 to the first is a little bit too small. 4 squared is a little bit too big, so the answer is somewhere between 1 and 2. Now I can't just condense them like I could in question 29 and 30 because there's only a single logarithm. So for this one, I think this is like what we did in section 3.2, where we should try to do this in 2 steps. So first I would raise it to something to lower this 4, lower the base. So I'm not going to do a cube root because the cube root of 4 doesn't come out to a nice whole number. But the square root of 4, exponent of a half, does come out to a nice whole number. And then 2 to what power gives us 8? 3. So I really want to raise it to a half, but I also want to raise it to a third. So to do both at the same time, 3 over 2. Which makes sense because that's between 1 and 2, which I knew the answer had to be between. So you just have to do it in 2 steps. Maybe if you got really creative, and I've never thought of it like this, but I'm probably biting off more than I can chew here. But instead of saying 8, you could maybe try like if you could come up with two numbers that add or subtract, no, not add or subtract, multiply or divide, we could do 4 times 2. 8's the same as 4 times 2, right? So again, you'd have to get really creative this way, but then you could say, I could expand this multiplication into addition, like this, and then this would be 1, and what would this be?
Just 1/2.
And 1 plus a half is 3/2. But again, you'd have to think of two numbers that either multiply or divide to 8 that would also work out nicely after that. But I guess that would be an option as well. So whatever you prefer there.
How'd you record that one?
It's one of the two I didn't have on the website, so just in case other people want to see it later.
Could you do 32?
Sure. $32 looks to be the same type of question, but let's see if we can figure it out both ways like the other one. So I know 8 to the first only gives me 8, which is not big enough. I need it to be 16. 8 squared would be 64, which is way too big. So I know my answer is between 1 and 2, and it's probably closer to 1 because 16 is closer to 8. It's not exactly proportional, but my guess is it's probably going to be closer to 1 than to 2. So how I would have had you do this in section 3.2 is since we know it's a fraction between 1 and 2, generally with fractions we can't just come up with the fraction right away. So if we do it in 2 steps, it makes it a little easier to digest. So I would not raise 8 to the 1/2. Raising to the 1/2 would be square root, and the square root of 8 doesn't come out to a nice whole number. That would be 2 square roots of 2. So in this case, I would do cube root, raise it to the 1/3, because the cube root of 8 is a nice whole number of 2. And if I'm trying to get it to be 16, now this is a lot easier for me to do in my head. 2 to the 4th power gives me 16. So if I want to raise it to the 1/3 and the 4th, I want to raise it to the 4/3. And again, as I guessed, the answer is slightly closer to 1 than it is to 2, because 16's a little closer to 8 than it is to 64. Okay, the other way that I thought of on the last question, which I don't know if I can do this that easily, but you could maybe think of 16 as, I don't know, 32/2 is the same thing as 16. And I think that would work out nicely, where you could expand this. Okay, that does not work out nicely. How about How about 8 times 2? That's 16. Oh yeah, that works out great. Because then you could expand multiplication into addition. And I picked 8 times 2 because this comes out to a nice whole number, and oh, no it doesn't. I don't know why I changed the base here. This should be base 8. Okay, this comes out to a nice whole number. This one's a little harder to see, but 8, the cube root of 8 is 2, and a different way to say cube root is to say an exponent of 1/3. So again, you got to be a lot more creative that way than the first way, but it at least relates the expanding and condensing together for you. Okay, anybody have any others ready to go? Yeah.
Can you go to 59?
59, sure. So again, at the end, 59, and then I think like the last two, they definitely look more intimidating. Questions are a little messier, but it should be the exact same skills. So I would first change this fourth root to an exponent of the fourth, because that allows me to bring it down. You okay with that? Okay, and then there's really only one more logarithm step. I've got x cubed times x squared plus 3, and multiplication is going to expand as addition. So it's going to stay natural logs. This was 1/4 times the whole thing. So when you expand it, it needs to be 1/4 times the whole thing, not just 1/4 of the first term, but 1/4 of both terms. And then actually, I guess there is one more thing. You really need to bring this 3 down, and you can't bring this 2 down because this 2 is only an exponent on x. It's not an exponent on what you're taking the log of. So I would stop there, or distribute the 1/4, whichever you prefer. But same thing, writing this as an exponent, knowing why this exponent can come down out front, and then expanding multiplication into addition. So again, much messier question, much more intimidating, but it's really the same skills. Okay, it sounds like you guys are getting pretty far through the assignment, but let me set one more 15-minute timer and try to finish up the rest of those questions, and then 15 minutes from now I'll let you finish up with whatever else you couldn't get on your own. Alright, as promised, give you guys one last chance. Anything else from the book assignment that you'd like me to go over with you on the board?
64.
Verse 64. Alright, 64 wants us to condense. So what did you try for your first step? Like that? Alright, you're done. There's not multiple logarithms, so you can't condense more than that. It's just that they're trying to hit home that if you're condensing, this needs to move up at the end of the question. So if you were expanding, they would expect it to be out front at the end of the question. Anything else? Yeah. 70 what? 72, okay. So 4 times the natural log of z plus the natural log of z plus 5. Then subtract 2 natural log of z minus 5. Okay, so this is a condensing question. So I know I've got to deal with these coefficients first. This 4 and this -2 are both a problem. But just my advice on these nastier, longer looking questions is try to do smaller steps. So just distribute the 4 the first time. Don't try to do too much at once. Then realize to condense, you can't ignore this 4, or this -2, but we could bring the exponents up to get them out of the way. Then I could condense these two, since they were separated with addition. I could condense them with multiplication. And then these two are separated by subtraction, so I could finish and condense those with division. And all of this stuff comes first, so it's going to be the numerator, and this stuff comes second, so it will be the denominator. That's what you're aiming for there. Now, one thing to keep in mind that I did not say earlier is, of course, you can check most of these. If the question asks you to condense, you could always check your answer by expanding. Now, I realize this one would be kind of a mess to expand because there's a lot going on there, but in theory, on a test, if you didn't feel confident in this answer, you could force yourself to try to expand it and see that it goes back to what you started with. And if it doesn't, then you either have a mistake or you're not expanding it correctly, but at least you would know to put some more thought into it. All right, is that enough? Okay. So again, I know this one, and then there's maybe one or two others that are also pretty scary looking, and we can do those if y'all need to. But again, at the end of the day, I distributed, brought up exponent so I could condense, condensed addition into multiplication, and condensed subtraction into division. So not anything that you didn't do on other questions. You just kind of have to get over the fact that it looks so much harder. Okay, any others y'all have ready to go? Okay. All right, y'all still have almost 20 minutes. So again, you don't have to have this turned in by class on Wednesday, but I would be surprised if you didn't have it finished by Wednesday. Again, I will not be giving you more class time to work on this, but I guess I probably won't ask for it until Friday. This is an A week, so I'll see you on Friday too. So if you're finished, go ahead and turn it into Google Classroom so you don't forget about it. And in these last 20 minutes, if y'all have any other questions, of course, you're welcome to come up and ask. So just let me know.